Carrying on with tutorial sheet 1, question 2, looking at part 3 now. We're asked to sketch and label a graph of x of 2t. I've written x of t that we had previously. So let's multiply this out. So we're saying that x of 2t, and now we're going to replace t with obviously 2t. So we're going to have 3u of 2t minus u of 2t minus 2. So what happens here? Well, let's have a look at what's happening at this point. We know that u of t essentially goes from 0 to 1 at time is equal t equals 0. So we're still trying to find out when the argument of this function equals 0. So when does 2t equal 0? Well, of course, t equals 0 at time 0. In fact, for any multiplication of t, it would still be at time 0. However, for this function, we're looking for the argument when 2t minus 2 is equal to 0. If I rearrange that, I get that occurs at time t is equal to 1. So now if I redraw the graph, we're going to get, so this is x of 2t, we're going to get an amplitude of 3 for the first part, and then we're going to, obviously we're going to have a reduction of 1 because it's a minus, and that occurs at time t equals 1, and then goes on to infinity. Related to that, question 4 asks us to plot x of t over 2. So a very similar manipulation. So just recalling the equation. And replacing t with t over 2. So we have 3u of t over 2 minus u t over 2 minus 2. And again, we're looking for when and what time does the argument of these two functions equal 0. So when does t over 2 equal 0? Well, at time t equals 0. And when does t over 2 minus 2 equal 0? Well, that occurs when time is 4. So if I was to plot that function, this is x of t over 2. In this case, we need to have the t equal 4, and we're going to have an amplitude of 3 up to time 4, and then we're subtracting down to amplitude 2, and then goes off to infinity.